Hello, I welcome you all. The problem reads the elevator E has its flight. The elevator E and its flight have a total mass of 400 kg. Hoisting is provided by the motor M and 60 kg block C. If the motor has an efficiency of 0.6, determine the power that must be supplied to the motor when the elevator is hoisted upwards at a constant speed of 4 meters per second. This problem is coming from the engineering mechanics and dynamics, 14th edition by RC Hibbeler. So let's say we have the weight. Let's assume it's acting through the center of gravity. Okay, so that's the weight, and let's section these particular cables there so to expose the tension. So we are going to have tension in these cables. So have tension here. This one is already known. So from there to there we know the value, and we know the value here. Alright, but this one we don't know these values. Okay, and so is this. Okay, so is this. Okay, right, so let's label this. So this one we have the same tension. So here we do have the weight. We have the weight there, and we know this value. Here we have the weight for this. So this is C, right? And therefore this one is WE. This one is just going to be equal to W also C. This is C, not E. This is C. This is also WC. So this is T, this is T, this is T, this is T, like so. Alright. What do we have? So we've been told that the speed is constant. The speed is constant. Okay. The speed is constant. Okay, therefore the acceleration ay is just equal to 0. So we do have motion upwards. This is ay, but this is equal to 0. Right. So if we apply the equation of motion like so, we know that ay is just equal to 0, going up in our reference. Then what we have basically here is we have T. So we have 3T plus WC minus WE equal to 0. Okay. Therefore, WE is known, WC is known, so let's find what 3T is. So 3T is just equal to WE WE minus WC, and this is just equal to 400 by 9.81 minus WC, which is 60 by 9.81. Therefore, 3t is just equal to, that's 400 by 9.81 minus 16 by 9.81. So this we get a 3335.4. Okay, so now we have found 3t. So I'll need to explain something here. When we look at the connection of the cables here, you realize that the motor is connected to these cables, right? These three cables. While this weight is not connected to the motor. And therefore, when it comes to calculating the power that is supplied to the motor, we are just going to use the cables that are connected to the motor, right? Or if you want to, you could determine the velocity in just this one cable and do everything else. You determine the velocity as well as the tension, where you just divide this by 3 and work out this the way it is. Or you can use the three cables as they are and use this as the force in the power equation. So we know that power itself, this is power out, is just equal to the force times the velocity, okay? And this velocity here is C, the VE. So this is just going to be equal to 3t times VE, and this is equal to 5.4 times 4. Okay, and therefore the power output just becomes equal to 3335.4, right, times 4, and this we get a 13,341.6 watts. But we have been told that the efficiency is 0.6, so we know that efficiency is just equal to P out divided by P in. Alright, and therefore the P in is what we are looking for. This is the power supply to the motor. So P input is just going to be equal to P out divided by efficiency, which is just equal to 13,341.6 divided by 0.6. And therefore, our P input is just going to be equal to this. We just get a 22236. Then if, all right, we can leave it like this if you don't want to, or you can write it as 22.2 watts. So let's just leave it like this. If you want 22.24 kilowatts, or you leave it the way it is. So this therefore is the final solution for our problem, and this is one of the ways you can solve this particular problem, and not the only way. You can use other methods. Like I said, if you don't want to solve this like this, then you can just use the T, all right, connected to the motor, as well as calculate the velocity using kinematics, and then you can still arrive at the same solution. Alright, I guess we are done, and I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.